All right, folks, in this video, I'm going to show you how to conduct a hypothesis test for paired data. So it's two samples and they're paired. This is pretty significant when you can say that the data is paired, and it usually occurs when you have something like you do something, you do a test, or you do some sort of activity, you do something else, and you see if there's any change in that behavior. So you take data before and data after. Data before pollution, data after pollution, data before feeding, data after feeding, data before exercising, data after exercising, something like that, right? What's absolutely beautiful about paired hypothesis test is this is my test statistic. And you might say, oh man, we're still in that world of two samples of data, but we're not anymore. We're not. This is the exact same thing as a one sample t-test. All we're doing is we're saying, hey, there's a difference between the two data sets. You take and you make a new data set. You subtract data set A from data set B, create a hypothesis test. Almost universally, especially with the problems that I give to my students, is this is 0. So it is d bar divided by root of n. So let's take a look at some data. So what I have here is a whole bunch of test scores. These are test scores before I gave a thorough and comprehensive review, and then I gave people the same-ish test. It had different problems after. Now, we want the same assumptions as we've always had. We want to make sure we have at least 30 observations and they're from independent data sets. They're not going to be independent, obviously, because these people did something and then did something else. That's okay, right? We're going to go ahead and leverage the data analysis toolkit again. Why not? It also has paired two sample for means. Huzzah. Could we go ahead and make ourselves a template, just take the difference between the two data sets and move on? Yeah, absolutely. But why don't we use our technology? Let's leverage it. Let's try this out and see how it works. If you watch the video on assuming unequal variances, this is going to be very, very similar. Okay. So let's say okay on this. These are the only two types of t-tests you will use in this data analysis toolkit. Never use equal variance, never use means. So I'm going to say okie dokie. It's asking me for the date range 1. There's date range 1. This is test range 2. My hypothesized means, I'm just going to say that I hypothesize that there's no mean, right? I could be interested in a grade increase of 5 points or 10 points or something like that. I'm just going to say that there's no difference in the mean. My null hypothesis is the first test is equal to the second test. I do have labels here, so I want to click on that. Alpha does not matter, and I'm going to spit it to a new sheet. Excel is churning. Awesome. Just like the two sample t-test, the paired means, I want you to notice a couple of things about the output for the paired means. It tells you the number of observations. They should be the same. You gather data for one event and you gather the same amount of data for the other event, okay? My p-value here is one-tailed, and it is doing the same. It is assuming that this lower number is smaller than the greater number. What this tells me is my efforts to do my reviews with the students were very successful, and it raised my grades by some number. I don't know how much it raised it by. It raised it, I mean, from this, it raised it on average about 14 points. And it is a significant statistical increase in the value. I highlight what's really interesting to me out of this data. And I have all of the materials I need to solve the problem. Even with an alpha as small as most alphas I've seen, this is such a significant difference that there is plenty of evidence to reject the null hypothesis and say that there is evidence that doing the review helps the students on the same similar material test. Okay.